Good afternoon and welcome to all listeners. Happy to see that this UNIGIS International U lecture is attracting so many participants. My name is Niels van Maan and I'm the UNIGIS Amsterdam coordinator and researcher at the Spatial Information Laboratory at the Vrije Universiteit Amsterdam. This semester we are hosting the U lecture webinars on behalf of UNIGIS International, a network of universities offering distance learning MSc programs in GIS. Today's webinar is concerned with smart mobility and geodata. Our first speaker, Gerrit Schipper, is a specialist in information science and has gained significant international experience in the automotive industry, dealing with the collection and distribution of traffic information. He will present a near-future vision on smart mobility, primarily from the perspective of the automotive industry. Our second speaker, Marianne Linde, is a member of the board of directors of Geodan, a Dutch company specialized in geo-ICT products and services. Within Geodan, she's responsible for launching new solutions for smart mobility and smart city challenges. Until 2015, Marianne was Director of Innovation at TNO within the program Urban Development. Marianne will present recent Dutch pilot studies in smart mobility, often in connection with other urban systems. From these pilots, she will reflect on the information infrastructure required to facilitate smart solutions in the urban environment, and possible strategies that we as GI professionals can adopt to help build such an information infrastructure. We encourage our listeners to post questions and remarks during the presentations using the chat box in the GoToWebinar interface. Please mention in your remark to whom the question is directed. I will moderate your questions at the end of both presentations. And now over to our first speaker, Gerrit Schipper. Gerrit, the floor is yours.
Thank you very much, Niels. I hope everyone can see my presentation at the moment. Well, as Niels said, my name is Gerrit Schipper. I have quite some knowledge gained about smart mobility in particular as a part of the smart city thing that's currently going on, and I'd like to share that with you. If we look at the automotive industries, there are a couple of mega trends that are actually driving building new cars, new vehicles in general. The first one is a shift in global economic power. In the past few years, the global balance of the economic powers has been shifting from the more or less developed to the less developed countries. And we see that if this trend continues, that it will have a tremendous impact on the growth opportunities that will arise for companies, in particular where they invest to capitalize on those opportunities. The second trend is the demographic shift, because in combination with the shift just described on spending power, the coming decade we will also see an explosive population growth in some countries and actually declines in others. And this will have far-reaching impacts ranging from growing pressure on the supply of critical resources to sweeping changes in, well, let's say, people's aspirations at both a personal and social level. And the third element in this is the acceleration of urbanization. Today, almost half of the world's population already lives in cities. And this is just the start of a steeping growth. And the only way for cities to cope with this trend is to actually become smart cities that enable smart mobility. And Marianne will later on give some examples on how cities are actually coping with this. The fourth megatrend is our technology or technological breakthroughs. Continuous breakthroughs in research and development ranging from nanotechnology to robotics, are opening up new opportunities. And this perpetual flow of ideas and innovation is creating ever more powerful enabling technologies that will help us actually coping with the challenges that we will be facing. And last but certainly not least, of course, is climate change and resource scarcity. Current estimates suggest that the world carbon emission range, which are a result of burning fossil fuels, will rise by 16% between now and 2030. And over the same period, the scarcity of national resources will increase substantially. And we will have to become more clever to deal with this. From these, as you can call them, mega trends, 3 themes have developed that color the development of the automotive industry. The first is a sharing society, and I will cover them next. Second, actually, is the automotive driving or autonomous driving. And the third one are electrical vehicles. Let's start with the electrical vehicles first. We've seen in the recent years that electrical vehicles has become really a fashion. They are seen as being very important towards managing emission challenges. The fact that we are currently having a number of electrical vehicles, and in particular in the Netherlands we see a lot of vehicles, is because of what happened in the United States, where at one point in time the CAFE standards, the corporate average fuel economy standards, were regulations that were induced in the USA to improve the average fuel economy of cars and light trucks. This was very important. That means that every manufacturer that had a fleet of cars that it manufactured had to have an average fuel economy that had to be below a certain threshold. And by adding electrical vehicles to the fleet meant that they could keep selling also the vehicles that were actually less good in this whole area. So this CAFE standard drove the whole electrical vehicle discussion. Of course, it can also lead to quite some excesses. We've all heard about the Volkswagen case. Volkswagen could only keep selling cars in the United States if their total fleet was below this threshold. And the only way apparently that they thought that they could do it in a very short term is by hacking their own software in the cars in such a way that the car knew when it was tested. And when it was tested, it then made sure that the emission at that particular test location was below the threshold. This was not very clever from Volkswagen to do, and the whole car industry is at this point in time really suffering from that. The positive thing about this is that now Volkswagen have decided to shift about $1 billion, or €1 billion actually, from their ordinary developments into the developments of smart self-driving vehicles. So, you know, who knows, maybe something good comes out of it. Where at first the car manufacturers thought that battery electrified vehicles were the way to go, we see in a very recent research now that fuel cell electrical vehicles are on the uptake. Also, again, we see that the downsizing of the ordinary machines have become less important. Apparently, there are some tremendous technological breakthroughs in the industry that make it possible to think about, again, about fuel cell electrical vehicles. Now, if you look at that picture of all these electrical cars, currently what has been thought of is that 68% of the new cars will be somehow electrical. This, of course, will have a tremendous impact on the electricity networks. And to be able to cope with that, we need a smart grid. Because on one hand, we will have electrical vehicles, battery electrified vehicles that need places where they can have their battery filled up again. charge their batteries. On the other hand, we will have fuel cell electrical vehicles that can actually act as small electricity producers. And to cope with, on one side, the demand, and the other side, the offering, together with all the things like solar power planes and smart houses, the electricity companies have to think about a smart grid. And to be able to design the architecture of such a smart grid, the geospatial intelligence is very, very important. To know exactly where people live, who of those people have electrified vehicles, whether they have also, in combination of that, solar power plant, solar power houses, whatever. It means that knowing exactly where what is and who has what at what location becomes even more important in the future than it is already today. If we look at the sharing society and the autonomous driving, there's a tremendous link between the two. On the left-hand side, in the bottom, you see this link. What we see from the sharing society is that the fact that people start to move to urban areas, have less place to have cars, for instance, but also things like Peerby or Uber or Airbnb means that people are more inclined to share things rather than own things. And this will also have a tremendous impact on the cars. Today, and that's already a 100-year-old model, OEM and suppliers or rental companies simply were focusing on the fact that most of the people own their own cars. And on the one hand, people believe that this owned thing will continue for a very long time. And we see today autonomous cars being sold already, like Tesla, Mobileye, Daimler, although it be a very high segment. We also see a lot of car manufacturers that believe that the shared economy will actually surpass that. So in the end, that we'll move to a shared autonomy with autonomous driving cars. The average of the industry executives is that there will be a kind of an 80-20 situation where still 20% of the vehicles will be owned and 80% of the vehicles will somehow be shared, or that we go to a new way of getting on mobility, like Uber today. Why should there be in 20 years time from now still a human driver in there? Maybe we can use our Uber app just to call up a self-driving vehicle. So this will be actually a very interesting thing that will happen. And again, also for this, we will need geospatial intelligence. Where are the people living that are willing to share stuff? Could be very interesting for marketeers to position new business models, whether it will be vehicles or other stuff. If we go to the autonomous driving area, then a lot of people think about sensors and what have you. Basically, some people call it an iPad on wheels, but that's only partially true, of course. The NHTSA has kind of designed 5 levels of vehicle automation. Level 1 is what we have today, no automation. Level 2 will have some single control functions, and that's available right now. Level 3 will have already combined functions automation. More than one control function is automated, but the driver is expected to be available from control at all times. You can think of situations where cars that stay in lane automatically combined with automatic parking and those kind of combined functions. It becomes more interesting when we go to level 4, where we already have limited self-driving automation and where the driver is, although expected to be available, he only is expected to be available occasionally with comfortable transition times. The industry believes that within the next 5 years, those cars will become available, and it might even be that it is sooner. Tesla has already tested the new software in its new Tesla in New York recently, where the car was driving pretty long stretches of road completely all by itself. So who knows, is 2020 maybe even it's going to be faster when we will have self-driving vehicles. And last but not least, of course, that's when we have the full driving automation, and that's the robot car. That's also the definition of what a robot is. It can think, it knows exactly where you want to go to. You can just sit and relax. You don't have to think about it, and you will be go from place A to place B. Now, many people think that this is not feasible, but if you see what the car industry itself says, it says that from already 2025, which is only 10 years from now, there will be full self-driving cars on the road. That means robot cars. And to make that possible, the industry is of course looking to all the things that they need to make that possible. And many people today think about self-driving cars, typically as we see on the screen now, the Google car, the Lurch Pathfinder in the UK, or Nissan's autonomous drive in Japan. But there's already something that a lot of people don't realize, is that we have already a lot of self-driving mobility. Think about public transport systems. Here we have some examples from the UK, but people feel already very comfortable to use these systems to go from place A to B. And although the underground may still be on rails, the vehicles at Heathrow Airport aren't. Also, the robot taxi that is being tested currently in Seoul, although again in an area that is not crowded yet, but it is already there. And let's not forget what happens in the Netherlands, in Wageningen at the university. Also there a taxi started with a transporter of human beings completely autonomously. So there's already more on the road than we probably were aware of. Interesting enough, the industry believes that the first kind of vehicles that will benefit from the new technology will be the truckers. Cars that are connected to each other wirelessly, platooning, 4, 5, 10 cars wide, particularly in the US, where the trucker behind the wheel can be relaxed, except for the first one. That is the first commercial use that is anticipated to be available pretty quickly. But things move pretty fast. Mercedes is already testing the future truck that it will think it will have available in 2025. This truck is completely autonomously. And as you can see, the driver has a very relaxed seat that also can be expanded to be a couch or a bed. This truck, of course, is designed for very long stretches, in particular in the United States and other areas like China, where this can be of a lot of use. Now, if we look at the technology that is required, many of the sensors are already in the car, but also a lot of the sensors will interact with the road. First of all, car will have information sent to the car by satellites, for instance, about where are certain objects on the road, like traffic signs. It will have sense, of course, where are other vehicles on the road, but it will also know exactly where the lines are, where curves are. This is all geospatial information that makes it possible for these cars to drive quite safely. If we combine this technology with the fact that cars will connect with each other, it will even become a much safer place. Virtually, cars that are all connected to each other can warn each other when we have eyes on the road, can warn each other when there is congestion, or when there is something happening to the system, like an earthquake that has shifted some rocks on the road, and so on. And thirdly, is what happens in also parallel is a complete fully automated infrastructure, where the infrastructure talks to the car. This is not just an infrastructure that talks to the car, but also an infrastructure that may even charge batteries for cars whilst driving. This infrastructure is clearly being thought of when we talk about smart cities being prepared for smart mobility. The whole car industry is anticipating this happening. And geospatial intelligence is very important. Of course, the canvas is still a basic map. That's where BMW, Audi, and Daimler have bought for $2.8 billion here from Nokia. But there are a lot of other things that's going to happen. With basic maps available, suddenly we see that these intelligent cars are able to give information back, where there are potholes in the road, where the road is somewhat different from what's on the map, where congestion always is. A combination of existing geographical information with geospatial intelligence make the world in this respect a much safer place and give us an opportunity to grow into smart cities. And what that can do and how we are testing those smart infrastructures and the combination between smart vehicles and smart infrastructure is something that Marianne is going to tell us all about. Thank you very much for your attention.